Yeah. Today's topic is data visualization, which is emerging towards data science. And through this lecture, we are going to see what is data science, its related terminologies, the need for data science, artificial intelligence versus machine learning versus deep learning versus data science. Then the data science life cycle, data visualization, and the tools and techniques for data visualization. Yeah, now we'll just come to our topic. What is data science? Actually, as a cumulative perspective on researchers, it is equal to the story Blind Men and the Elephant. In the case of first person whose hand landed on a trunk said that this being is like a thick snake. For another one whose hand reached its ear, it seemed like a kind of fan. As for another person whose hand was upon its leg, said that the elephant is a pillar-like tree trunk. The blind man who placed his hand upon its side, he said elephant is a wall. Another one who felt its tail described it as a rope. The last one who felt that which is hard, smooth, and it's like a spear. So, as the world entered the era of big data, the need for its storage also grew, and the decision from that large amount of data, it becomes very difficult for us. So actually, data science is the secret sauce here. Now, what is data science? A groundbreaking study in 2019 reported 90% of the entity of world's data has been created within previous 2 years only. Every company will say they are doing a form of data science, but they don't know exactly what it means. The simplest definition of data science is just the extraction of actionable insights from the raw data. We are just extracting the insights from the raw data. We all heard about machine learning, artificial intelligence, IoT, etc. But what is the one thing that underpins all those revolutionary technologies? The answer is data. From social media to the IoT devices for generating immeasurable amount of data. Consider the cab service provided by Uber. I'm sure all of you have used Uber. What makes Uber a multi-billion dollar worth company? Is it that availability of cabs? Or is it its service? No. The answer is data. Data makes them very rich. But wait, is this enough to grow a business? Of course, it is not. You must know how to use the data to draw useful insights and solve problems. This is where data science comes in. In simple words, data science is the process of using data to find solutions or to predict the outcomes for a problem statement. Okay, let us see how it affects our day-to-day activities. For example, if you consider it is a Monday morning and I have to get to my office before my meeting or my class starts. So I quickly open up Uber and look for cabs. But there is something unusual. The cab reads a comparatively higher desire of the day. Why? Why does this happen? Well, obviously because Monday morning are peak hours and everyone is rushing off to work. The huge demand for cab leads to increase in the cab fares. We all know this, but how all of this implemented? Data science is at the heart of Uber's pricing algorithm. The search pricing algorithm ensures that their passengers always get a ride when they need one. Actually, even if it comes at a cost of any inflated prices. Uber implements this data science to find out which neighborhood will be the busiest so that it can activate search pricing to get more drivers on the road. In this manner, Uber maximizes the number of rides it can provide and hence it benefit from this one. Okay, Uber search pricing algorithm uses data science only. See, this is the best example of data science. Now in all activity, this data science has made remarkable changes in today's market. Suppose if you look for shoes on Amazon, but you are not in a condition to buy at that time. Okay, you're always searching shoes in Amazon. Now, the next day, you are watching videos on YouTube and suddenly you see an ad for the same item, that is the shoes in which you watched earlier. Or else if you switch to your Facebook, there also you see the same ad. So how does this happen? Well, this happens because as Google tracks your search history and recommends ads based on your search history. This is one of the coolest application of data science. In fact, 35% of Amazon's revenue is generated by product recommendation. And the logic behind product recommendation is data science. The next one is actually I would just like to feel the difference between your traditional versus data science. Normally in your traditional programming, you are just feeding your input along with the data and we are getting the output. That is, you know you are programming. With the help of programming, we have an input feed into the computer and we are getting the output. But in the data science, it's vice versa. We have data, we have output, we have input, and these data and input feed into the computer to get a program, not the output as in your traditional programming languages. Yeah. Now I'd like to quote some examples. With the help of examples, I'd like to give you what is the need for the data science. I think you must have already heard about autonomous cars. So I'm sure you must be excited to have a car driving by itself, which will take you from home to office or office to home, right? And that's where one of the examples where data science is used. And the car needs to take a lot of decisions in this whole process, whether to speed up or whether to apply brake, take a left turn, right turn or slow down. So all these decisions are basically a part of data science. And there is a study that says that self-driving cars will maximize accidents. And in fact, it will root out more than 2 million deaths caused by car accidents annually. Self-driving cars right now, there is a lot of research and there is a lot of testing going on. And I think not a lot of cars or 18 protection in usage, in terms of usage, but I think it's going to happen. Every automotive company worth its name in investing automated cars or self-driving cars only. So in about 10 to 15 years, some of the studies it say that most of the cars will be autonomous or self-driving cars. For another example, if you take is airlines. This is another area where data science contributes in a major way. Flights gets delayed due to weather conditions because the weather is not predicted in time, and the demand of passengers is also not probably seen ahead of time. For all these, you need only data science. Due to improper route planning, and some customers might miss some flights, that again needs data science. And similarly, it could be incorrect decisions in selecting the right equipment. So which plane should fly in which route, that's the equipment that's being mentioned here. If that is not planned properly, then you might end up in a situation where the plane is not available. If you have planned for a flight in a particular route, so there are some challenges for airlines. So if you use data science properly, all of these or most of these problems can be avoided, and that it will help in reducing the pain both for the airlines and also for the passengers. Also, we can do better route planning so that there are less cancellations and less frustrated people. We can use predictive analysis and predict any delays that are there, so that some flights can be rescheduled ahead of time and there are no last minute changes. We can avoid that. Another example by which data science can be used and benefited would be in logistics. So companies that are using data science models to increase their efficiency drastically, to optimize the roads and cut costs and so on. So before their delivery truck actually sets out, they determine which is the best possible route to ship their items to the customers. And based on various inputs, they also predict or come up with the best suited time to deliver. And last but not least, they determine what is the best mode of transport for this delivery as well. So, what is data science used for? See this diagram? These are some main areas where data science is used for better decision making. Actually, there are always truly some important decisions to be made, and which should also be a right decision. So which way to go? So that the one area is data science. Then for performing predictive analysis, like for example, can we predict delays like in the case of aircraft or airlines? Can we predict the demand for certain products? Another one is pattern discovery, that is the pattern recognition. Is there any pattern in which people are buying items? For example, it could be seasonality. Maybe if you take the sales data for multiple years, there may be pattern in which way people are buying. That's a buying pattern. Certain months, probably the sales will increase. Certain months, probably the sales will come down. Certain quarters, traditionally the sales will be higher. Certain quarter, it may be lower. That is a pattern. And this pattern discovery is another area. Pattern discovery is another area where data science we are going to apply. So what is data science? Now, again, let us take a real-time example or real-life example on day-to-day basis. Let us say we want to purchase some furniture online for our new office. So how do you go about doing this? You need to take a bunch of decisions to actually do the purchase. So we start with which website you can search, because there are several websites, so that this is the first decision you need to take. Which website I should use? Then only we can have we have to find out what is the rating of this website. By seeing the rating of this website or more, that means whether it is reliable, whether the quality is good and so on, you are able to buy that particular website if it is authenticated. So that other things you can if you take some criterias like the discount or the model, whatever it may be, if it satisfies your criteria, then you can prefer that website. Otherwise, what we will do? You close all those websites. That is, close in the sense you close the browser, that's all. You started searching another website which match your criteria, right? Go ahead if you wish and select the furniture and purchase it. This is the best way, or this is the best example. So we can answer a lot of questions using data science, right? Prediction is a very important success tool in your data science, right? Now, see what are all the various steps in data science. The first step is asking the right question and exploring the data. Basically, you want to know what exactly is the problem and you are trying to solve that problem. So, that is asking the right question, and now you are able to collect data from those questions. You can perform some exploratory analysis using the data. For example, if you need to clean the data and make sure everything, that's also fine, no issues. So first step is, for collecting the data, you should ask a right question. Then you need to do the modeling. Let us say if you have to perform machine learning, you need to decide which algorithm to use and what model to use, and then you need to train the model. Then only you can run your data through this process and you can come out with the final result of this exercise, which includes visualizing the results and preparing a best way to communicate the result to the concerned people. So it could be in the form of PowerPoint slides, or it could be in the form of dashboards, which is basically what we call as a visualization. And so all the insights that have been gathered through this exercise, that has to be communicated in a proper way, in an easy to understand way also, which is again a key part of this whole exercise, communicating the results. Okay, so what are all the steps for a good data science project? The first one, need to collect the data by questioning, that is right questioning. Second one, we are going to perform the predictive analysis and then explore the analysis to the users through any visualization tools. The communication should also matters. The communication should be in a very proper way. Now, I'd like to give some differences between business intelligence versus data science, depending upon the criteria, some criteria. Okay. So first one, business intelligence was one of the initial phases where people started making some sense out of data. So far, some of you who may not be aware of these multiple phases, this IT revolutions, initially there was some automations. So you had your selling of process data or selling data, manufacturing process data, or you had your ERP systems, relationship management, payroll management, wherever we are seeing in this business intelligence is collection of data. All this CRM, ERP, they were generating a lot of data, so that people started saying that we need to understand or get some information from the collected data or out of these data. So business intelligence was primarily using structured data. So you had all your enterprise applications like ERP, CRM, payroll processing were working out of RDBMS or relational DBMS like Oracle, MySQL, etc. Okay, and so on. So all these data were structured in a neat form, that is in a structured format in the form of table. That is, it is very much aligned in the form of table, that is rows and columns. They were well brought into a centralized place, centralized database management system. Even though they are scattered, we are able to accumulate those DBMS, relational database, in a structured format. So I think there will not be any problem in retrieving data using this structured database. Now, if you see your data science, in addition to structured data, we are using a lot of unstructured data. That is, for example, if you consider weblogs or comments, if you are talking about customer feedback, there is a structured part and also there is an unstructured part where people write free text. They can include their smileys, they can use their Tanglish words, they can use some commentary words. Okay, there is an unstructured part in which we are unable to regularize it using business intelligence. So we are in need of data science. The data science, it consists of both structured data as well as your unstructured data. This data science includes, I think, as well everything that perform your analysis also. So the business intelligence, it is in analytical sense. If you have some data, we are just able to present its truth only, analytical truth only, but we are unable to do any scientific process. Okay, in case of data science, we can go beyond that. We can go deeper in terms of finding why a certain behavior has occurred, and also we can go beyond just by providing a deep report. There is a deeper statistical analysis. That is what the scientific part and the deeper insights are gathered, not just reporting as in case of business intelligence. Business intelligence needs a little bit of statistics but more visualization because they primarily consisted of dashboards and reports. Whereas in data science, the visualization of course is there, but there is a lot more of statistics involved, because we are looking at things like correlation, predictions, regressions, and using these regressions and all, we are trying to predict what will be the sales maybe in future in sales marketing or using sales data. Okay, what was my sales maybe for this whole year or for the last 5 years, but using business intelligence we cannot do such predictions. In data science, you can take the historical data, but you can also combine that with many, that is your required information with regression, correlation, statistics. What are all the mathematical concepts we can have, we can try. We can try to extrapolate using the data in your data science. Okay. Then the next one is prediction. If you consider, there are some essential triads required for a data scientist: future, present data, and he is able to predict the future with the help of present data. We don't have any future data, right? We are able to collect only the present data. We can get information, that is past historical informations we have. Using this present data, any data scientist can detect your future predictions also. Okay, so I think there are some essential traits required for a data scientist. The first one is the curiosity. You need to be able to ask questions. That is the first step in data science. First step in data science, I think. Yeah. First step in data science is that we are able to ask questions. What is the problem we are trying to solve? Or if you are able to write question only, then you will get the right answer. This is a very crucial step where a lot of data science projects fail, because you may be asking the wrong questions, and then obviously when if you collect that wrong questions, you may be getting only the wrong answers. So the first very important one is asking the right question. The second protocol is common sense. You need to collect creatively, you need to collect the data. You need to come up with ways to use the data that you have and try to solve the business problem on hand. In many cases, you may not have all the data that you need. In many cases, the data may be incomplete, so that you need to come up with the ways, what are the best ways to fill up these gaps. The only area we can concentrate to fill up these gaps is the communication. That is right communication, right communication to the customers, so that you are able to fill up these gaps. Now, I'd like to differentiate artificial intelligence, machine learning, deep learning, and the data science. The most fundamental thing in data science is to know the difference. Without knowing this difference, we all think machine learning, deep learning, and data science, they are one and the same, right? So I think this Venn diagram, which predicts, you are able to easily know the topic from this Venn diagram. Okay, I'm going to tell you what exactly is artificial intelligence, what exactly is machine learning, what exactly is deep learning, and what exactly is data science, and how do we use data science. The main work of artificial intelligence, you have heard of artificial intelligence applications, you have heard of many projects in artificial intelligence, right? But what is an artificial intelligence? Yeah, first, what is artificial intelligence? Artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also be applied to any machine language or any machine that exhibit traits associated with the human mind, such as learning and problem solving. This machine learning, actually it is a subset of artificial intelligence. And what does machine learning helps us to do? It provides us statistical tools to explore the data. Okay, it provides us some statistical tool to explore and understand about the particular data. In machine learning, you have three different approaches. One is supervised learning, second technique is called unsupervised learning, and the third one is called reinforcement learning or semi-supervised machine learning. So in machine learning, we have three different types. The first one, supervised, second one, unsupervised, and the third one is semi-supervised or reinforcement learning. Supervised learning will be having some labeled data. You have some labeled data, some past data, or with the help of these kind of data, we will be actually able to do the prediction for the future. Let me take a very good example. Suppose I have two features in my data sets. Example, my height and my weight. And I want to classify whether that person will belong to a obese category or whether he or she belongs to a fit category. Okay, so this supervised learning will be helpful for this kind of predictions. Okay, so we have to create a model, train on that data. We have a testing and we have a training data for training this model. So we have a labeled data. Okay, so we know what will be the output of this particular data. Now, the second category is the unsupervised machine learning. It will not have any labeled data. In my data science, I will not know what is the output. So, in unsupervised machine learning, usually we can have a clustering. Either it may be k-means clustering or hierarchical minimum clustering, whatever a clustering it may be. We have some mathematical concept called Euclidean distance in those unsupervised category, but the target, that is the output, when compared to structured, is entirely somewhat vague than in your unsupervised learning. Okay, then come to the deep learning. Actually, it is also a subset of machine learning. Artificial intelligence, then machine learning is a subset of artificial intelligence. Deep learning is again a subset of artificial intelligence. The main idea behind this deep learning is to mimic human brain. You know how human actually learns, right? These concepts, similarly, we are creating models over here which is learning those things, and the most important thing is multi-level network architecture, right? Actually, in multi-level architectures, we have various technique that artificial neural network comes in clubbing with your deep learning technique. Okay, so you using your neural network concept, we are able to do deep learning. So automatically now the question arises, what is data science? Now data science is a technique which we can try to apply all these techniques, that is machine learning, artificial intelligence, deep learning, which can be clubbed together with some mathematical formulas like statistics. Or probably you have probability theorem, or you can have different linear algebras, differential calculus, etc. So data science, a data scientist will have to work based on the type of the use cases it is having. Then we will come to the second part of data science. That is a very important concept, the life cycle of data science. Often we talk about data science project. Nobody seems to be able to come up with a solid explanation of how the entire process goes from gathering the data all the way to the analysis and presenting the results. So I break down the data science framework, talking you through each step of the life cycle while discussing, okay, what is the key skills and what the requirements are. The first step of a data science project is straightforward. We obtain the data that we need from available data sources. In this step, you will need to query databases using technical skills like MySQL to process the data, or you may also receive data in file formats like Microsoft Excel, tables, DBMS format, SQL, etc. If you are using Python or R, they have specific packages that can read data from these data sources directly into your data science program. The different types of databases you may encounter are like Postgres, SQL, Oracle, or even non-relational databases, NoSQL, or like MongoDB. Okay. Another way to obtain data is to scrap from the websites using scrapping tools. Another popular option to gather data is connecting to web apps. Websites such as Facebook and Twitter allows users to connect to their web servers and access their data. All you need to do is to use their web API to crawl that data. After obtaining data, the next immediate thing to do is scrubbing the data. This process is actually for us to clean and to filter the data. Remember the garbage in and garbage out philosophy. If the data is unfiltered and irrelevant, the results of the analysis will not mean anything. It is we can just throw the data in the dustbin. Okay, so it should be a filtered data or the pre-processed data. In this process, you need to convert the data from one format to another and consolidate everything into one standardized format across all data. Standardized format across all data. For example, if your data is stored in multiple CSV files, then you will consolidate, you can club this CSV data into a single repository so that you can process and analyze it. In some situations, we will also need to filter the lines. For example, if you are handling logged files. Logged files refer to web logged files where you get to understand data such as the demographics of the users, time of entrance into your websites, etc. On the top of that, scrubbing data also includes the task of extracting and replacing values. If you realize there are missing data set or they could appear to be a non-values, this is the time to replace them accordingly. Lastly, you will also need to split, merge, or you can extract columns from the data set. For example, for the place of origin, you may have both the city and state. Depending on your requirement, you might need to either merge or split those data. For example, Tamil Nadu and Chennai district, you can put it in a single column, or you can merge those two data in a separate column also. This is the best. Okay. Actually, suppose if you want to remove some data which is no longer needed, replacing what is missing and standardizing the format across all the data collected. You will need scripting tools like Python or R to help you to scrub the data. For handling bigger data sets, you are requested to have skills in Hadoop. Hadoop is a very emerging tool for doing these data science projects. Okay. Then the third step, this is your third step, is to explore the data. Once your data is ready to be used, and right before you jump into artificial intelligence and machine learning, you will have to examine the data. Usually in a business environment, your boss will just throw you a set of data and it is up to you to make sense of it. So it will be up to you to help them figure out with a business question and transform them into a data science question. To achieve that, we will need to inspect the data and its properties. Different types like numerical data, categorical data, ordinal data, nominal data, etc. require different treatments. For each and every data type, we need a different treatment. Not the same treatment will be applicable for all the data. The next step is to compute descriptive statistics to extract the features and test significant variables. These testing significant variable often is done with correlation. For example, explore the risk of someone getting high blood pressure in relation to their height and weight. Do note that some variables are correlated, but they do not always imply causation. The term feature is used in machine learning or modeling is the data features that help us to identify, or it is used that characteristic that represent the data representation. For example, name, age, gender or typical features of members in an employee data set, so that we can identify unique identity for a person or a data in a data set. Lastly, we will utilize data visualization to help us to identify significant patterns and trends in our data. We can gain a better picture through simple data chart like data charts or bar graph or histogram, whatever which is ideal for that project. It will help understand the importance of the data set. Okay, if you are using Python, you will need to know how to use NumPy or pandas. If you are using R, you will need to use ggplot or the data exploration Swiss knife dplr. On top of that, you need to have knowledge and skills in inferential statistics and data visualization. The fourth step here, this is the fourth one, is to model the data. This is the stage where most people consider very interesting, as many people call it where the magic happens. Once again, before reaching this stage, bear in mind that the scrubbing and exploring stages are equally crucial to building useful models. So, take your time on those stages instead of jumping right to this process. One of the first thing you need to do in modeling data is to reduce the dimensionality in your data set. We can call it as feature reduction also. Not all your features or values are essential to predicting your model. What you need to do is to select the relevant ones that contribute to the prediction of results. There are few tasks we can perform in modeling. We can also train models to perform classification to differentiating the emails you received as in your inbox and spam using logical regressions. We can also forecast fake using linear regressions. We can also use modeling to group data to understand the logic behind those clusters. In short, we can use regressions and predictions for forecasting the future values and the classification to identify and clustering to group the values. For doing these, if you are using Python, you will need to know how to use scikit learn. And if you are using R, you will need to use caret. These are all the two tools which is available in Python and R. The fifth step is interpreting data. We are at the final and most crucial step of data science project. Interpreting models and the data. The predicting power of a model lies in its ability to generalize. How do we explain a model depends on its ability to generalize unseen feature data. On the top of that, you will need to visualize your findings accordingly, keeping it driven by your business questions. It is essential to present your findings in such a way that it is useful to the organization. In this process, technical skills only are not sufficient. One essential skill you need is to be able to tell a clear and actionable story of your presentation, which does not trigger actions in your audience. It means that you need that your communication was not efficient. Remember that you'll be presenting it to the audience with no technical background. So the way you communicate the message is the key. Actually, handling a customer which is not having computer science background is very difficult. Already we computer science people, we can have an experience that even for doing some manipulations in Excel, it is very difficult to teach a person who is from non-computer science background. That is the same problem we are exploring here. Presenting your project to an audience with no technical background is very tough. So your communication should be in a very efficient way. Now, moving to the life of data scientist. Data scientist. We are, of course, we can call ourselves a data scientist, right? What does a data scientist actually what is the role or what he is going to do during the course of his work? So let us see what the role of data scientist. Okay, so typically a data scientist is given a problem, a business problem that needs to solve, and in order to do that, if you remember from the previous slide that he basically asked the question as to what is mainly the problem that he needs to solve. He should understand what he is going to do. He can extract it from the problem. Okay, so the first thing is he has got the problem, and the next thing is to gather the data that is required to solve the problem. So he goes about looking for data from anywhere. It could be the enterprise, or it could be from any questionnaire collected from the customers, whatever it may be. It could be the enterprise. Very often the data is not provided in the nice format that he would like to have it, or we would like to have it, or just we can exclude it. So the first step is to get whatever data that is possible. What is known as, actually it is known as raw data, in whatever format. So it could be some public data. In some cases raw data is collected and it is processed and analyzed, and it is prepared in a format in which it can be used, and then it is fed into the analytic system. It can be a machine learning algorithm, or it can be a machine learning algorithm, or it can be a statistical model, and we can get the output for presenting it to the stakeholders and communicating those insights or result to the stakeholders. Okay, so this is a very high level view in the life of a data scientist, gathering raw data, performing some quick analysis on that, and maybe processing or manipulating this data to a certain good format so that it can be used for the analysis, feeding this into that analysis system that has been designed, he has to do some mathematical models also. Okay, then machine learning models, or you can use any machine learning models. Then get the results, the insights, and then present it in a nice way so that the stakeholders can understand. How about machine learning algorithms, or understand the solution from which, or the way in which the data scientist presents. This is a meaningful work of data scientist. Actually, 25 years ago, he is just using statistics, and 20 years ago, he is doing data mining, that is data cleaning, pre-processing, etc. 10 years ago, he is doing predictive analysis. Now, he is really do the job of your data scientist. That is, he is just producing the information from the raw data. So the work of a data scientist is to transform the raw data, that is the unmeaningful data, into a useful insight to make a better business outcome. That is converting a raw data into knowledge, then into wisdom. So actually, the process of data science is to convert the raw data into knowledge, into wisdom. Okay. Now, we are in our second part of our lecture, that is data visualization. You all know from the school days onwards, that is always our professors used to say, a picture is worth than 1,000 words, right? So before we move on, it's important to understand what data visualization is and the purpose behind the data visualization. Data visualization is the representation of data in a visual format, just in a visual format. The purpose of visualizing data is to summarize and present data with easily understandable visualizations that highlight a key message from the data to the readers. A visualization that distorts critical messages hinders the ability to make meaningful or accurate decisions. It is a graphical representation of information and data. We need data visualization because a visual summary of information makes it very easier to identify the patterns and trends that than looking through thousands of rows in a spreadsheet. The amount of information that humans gain through this various visualizations is very, very, very important through vision. So, by using visual elements like charts, graphs, and even maps, data visualization tools provides a very accessible way to see and to understand trends, outliers, and patterns in data. It is hard to think of a professional industry that doesn't benefit from making data more understandable. While we will think always wax poetically about the data visualization, they are practical, they are real life applications that are undeniable. And since visualization is so prolific, I think it's also one of the most useful professional skills to develop. The better you can convey your points visually, whether in a dashboard or a slide deck, the better you can leverage that information. Leveraging your information is a very important one. Of course, one of the best way to understand data visualization is to see it. What a crazy concept, no? Data visualization. You are representing your data in a picture in a very easy, understandable way to the customers. When you think of data visualization, your first thought probably immediately goes to simple bar graphs or pie charts. While these may be an integral part of visualizing data and a common baseline for many data graphics, the right visualization may be paired with the right set of information. A simple graph or only the tip of iceberg. There is a whole selection of visualization method to present your data in a very effective and interesting ways. We will see one by one. Okay, the best data visualization on the market have a few things in common, but I think first is their ease of use. There are some incredibly complicated apps for visualizing the data. Some have excellent documentation and tutorials, and they are designed in a ways that feel very intuitive to the user. The best tools can also handle huge set of data. In fact, the very best can ever handle multiple sets of data, not a single set, multiple sets of data in a single visualization. Technically, the simplest understanding of data visualization is the mapping from data space to graphic space. Generally speaking, R language, ggplot, and Python are used in academia. The most familiar tool for ordinary users is Excel. Even Excel you can do visualization. The most familiar tool for ordinary users is visualization, where commercial products include Tableau, Fine Report, Power BI, which is a Microsoft product. Okay. Tableau is a very business intelligence tool for visually analyzing data. Users can create and distribute interactive and shareable dashboards depicting trends, changes, and densities of data in graphs and charts. Tableau can connect to files, relational data sources, and big data sources to get and process the data. It doesn't force users to write some custom code. The software allotted data mixing and real-time collaboration, but it is expensive. Okay. Now we will see one by one the various techniques of data visualization. The first one is bar chart. Bar charts are used for comparing the quantities of different categories or groups. For example, values of a category are represented with the help of bars, and they can be configured with vertical or horizontal bars with the length or height of each bar representing the value. If you use a bar chart, use consistent colors and labeling throughout so that you can identify the relationship more easily. Simplify the length of y-axis labels and doesn't forget to start from 0. So you can keep your data in order. You can have a question: why do I use bar chart visualization? The answer is you want to compare two or more values in the same category. You want to compare parts of a whole. You don't have to too many groups. If you want to understand, for example, if you consider this chart, here it is represented using various colors. You are able to understand the deviations. Here I am just considering the COVID-19 confirmed cases from 14 March till the second week of May, right? So you want to understand how multiple similar data relate to each other using this bar chart. The next one I'd like to project the technique is your histogram. Actually, a histogram, it representing the distribution of continuous variable over a given interval or a period of time, is one of the most frequently used data visualization technique. It plots the data by chunking it into intervals called bins. It is called bin 20 to 44, 45 to 54, 55 to 64. Actually, here also I consider the COVID data set, COVID-19 data set. The age group here differentiating is called the bin. It is used to inspect the underlying frequency distribution, outliers, skews, and so on. Histogram gives an estimate as to where values are correlated. What the extremes are, whether there is any gap. For example, if you take the age group of 20 to 44, how it is correlated? Whether there are any gap or unusual values throughout your data set. Remember, if you are using histogram, avoid bars that are too wide, that cannot hide important details, or too narrow that can cause a lot of noise. Use equal round numbers to create bar slides. Okay. Use consistent colors and labeling throughout so that you can identify the relationship more easily between the values. Here also see the values between 45s and 15s. If you consider the labeling with too wide, you cannot identify the relationship between the values very easily. The next technique in data visualization is a scatter plot. Okay, this is a common visualization technique. It is a two-dimensional plot representing the joint variation of two data items. Each marker, that is symbol such as dot or squares, and even you can use plus symbols, represents an observation. Each and every dot here, it is a representation. It is an observation. The marker position indicates the value of each observation. When you assign more than two measures, a scatter plot matrix is produced that in a series of scatter plots displaying every possible pairing of the measures that are designed to the visualization. Scatter plots are very useful for examining the relationship or correlation between x-axis and y-axis variables. Although trend lines are a great way to analyze. See, this is called as a trend line. 200x, 100x, 50x, 20x, 10x, or the trend lines. The data on a scatter plot. Ensure you stick to one or two trend lines only to avoid confusion. Otherwise, you are unable to predict the information or the knowledge from this plot. Don't forget to start at 0 for this x-axis. Here you have to start at 0. Otherwise, it is very difficult to analyze from the beginning of the values. Okay. When do I use a scatter plot? We can have this question. You want to show the relationship between two variables, or if you want to do a compact data visualization. Okay, so here also I'm just using the COVID-19 cases, test cases conducted against the confirmed cases. So this is a test total cases and this is the confirmed cases, and I'm just downloading the data set from our github.com website, COVID-19 data. Okay, the next data is time series plot. Do you know the one thing that cannot be stopped? Yes, that's the time. Time marches on no matter what we do and what we analyze. Many things with respect to time we have. A time series plot is a graph where some measure of time is the unit on the x-axis. We label the x-axis the time and the y-axis the variable that is being the measured data. Data points are plotted and generally connected with the straight lines. See, This is the straight line connected between one point to another point, which allows for the analysis of the graph generated. This is an excellent way to visualize long sequence of data. That is the time which is a continuous one. So here also I am just using COVID cases, but here I am just taking the recoveries, the recovery rate with the time. So from Jan, how many recovered cases? 5%. Then on March 11, it is up to 55 cases. The red line is the death case, and blue line depicts the confirmed cases. So this is a time series plot so that we are able to understand the recoveries in percentage with related to time. So this is best way to visualize the long sequence of data. The next technique we are going to see is heat map. A heat map is a data visualization that shows the relationship between two measures and providing rating information. The rating information is displayed using varying colors or saturation and can exhibit ratings such as high to low or low to bad, or some bad to awesome, and we need improvement to working well. It can also be a thematic map in which the area inside recognized boundaries is shaded in proportion to the data being represented. Use a simple map outline to avoid distraction from the data. Use a single color in varying shade to show the changes in data. Avoid using multiple patterns. Okay, we can here also we can have a question. When do I use heat map? To show a relationship between two measures, to illustrate an important detail, to use a rating system. It is useful. It is very much useful for two purposes: for visualizing correlation table, the relationship between one data and another, or the data which depends, one data depends on another data. And for visualizing missing values in the data. Note that heat maps are always useful when examining large number of values, but they are not a replacement for more precise graphical display such as bar chart, because color differences cannot be perceived accurately. For example, here COVID heat map, economic disruption will disproportionately impact some industry sectors more than others. See, this is a moderate exposure, high exposure, low exposure of potential positive impact. Okay, so that is a problem in heat maps. So normally people avoid using heat maps. The next one is the tools for data visualization. The data visualization tools, it may be available open source, or we can pay and use the tools. For data to be useful to humans, we are able to visualize it in a way that lets us understand the story it tells and communicate it to others. Data visualization tools are constantly evolving to offer more powerful features while improving accessibility and user friendliness. Today's top visualization and dashboarding tools are cloud native, so they are able to connect with your data wherever it is stored. For example, Tableau. Here you see this Tableau. This Tableau is the grand master of enterprise data visualization tools. But that doesn't mean it will be the perfect solution for everyone. Tableau has been considered as one of the leaders in data visualization for some time and also works as a comprehensive cloud-based analytics solution, providing all of the business intelligence capabilities, but it is its power and flexibility when it comes to gathering graphical representation of data. It is more renowned for visualization. Is baked into the Tableau's functionality, right down to its user interface, and designed to help the user make more better decisions about the most efficient way of extracting the data that we can communicate using the picturization of data. This Tableau is a very effective tool only. Okay. Then the next one I'll just wish to project is this Microsoft Power BI. Power BI, Microsoft Industry Standard Business Analytics platform, offers a very useful and intuitive data visualization functionality. This Power BI makes it simple for someone with no proper experience to start creative interactive dashboards and chart from the enterprise data. Actually, if you don't have any knowledge, no problem. You can use Microsoft Power BI. It will be very user friendly, as we can use it for cloud based business services. It is designed to allow teams to work collaboratively on data projects. That is the main very important feature of this Microsoft BI. We can work in teams in your projects. And also it allows queries to be made in natural conversational language with the results quickly rendered in clear and eye-catching graphics. Actually, Power BI comes with a good range of templates and visualization options with new ones for free. Actually, it is available for free, and you can purchase on Microsoft Azure Marketplace. But it is providing all the features free of cost only. And it is doing some affordable prices starting from $10 per license. Either you download it. Some features are missing in free version. That's all. Okay. The next one. Actually, this is your Tableau public screen in which I used, and this is your Microsoft BI screen. And the most interesting one is our Google. Always, wherever we are using searches, Google, right? So here, Google Data Studio is definitely a very interactive favorite in terms of free data visualization tools. Data Studio integrates the data from a variety of sources for reporting and analysis. Data Studio is even free, which remains the most significant differentiating factor when comparing Data Studio with Tableau or Power BI. It is very easily. It has a simple drag and drop interface. See here, you can start it for free. Very simple. Simply drag and drop interface. You can easily add charts and build reports without need of anyone help which is having deep technical knowledge. It is very simple. It doesn't take long to get the hang of basics. It is very quick to create a dashboard. See, using my login, I created this Data Studio. We can have reports, data sources, etc. Data Studio consists of two parts. Actually, the dashboard and the data source. There are currently 18 Google connectors with which we can connect different Google platforms directly into the Data Studio. No merging, no importing, just here you can create it, you can share it with any recent data set with this Data Studio. Okay, one of these connector is Google Sheet, which makes that any data you can get into a Google Sheet is accessible for visualizing in Data Studio. In addition, you will see direct file uploads. For example, if you have a data source, by using this data source tab, you can directly just click and you can see directly from the file uploads. You can also import from popular SQL databases, Oracle queries, BigQuery, Google Analytics, YouTube ads, Google Cloud services, etc. We can take data from anywhere. It is very easy for you to import the data also using this data sources. See how many templates, excellent templates you have. You are able to just present your data in a very efficient way using this data source. Okay. I think now we are in the concluding session, right? I'll just to conclude this data visualization. Actually, effective data visualization is a very crucial step of data analysis. Without it, important insight and messages can be lost. Okay, so good data visualization should communicate a data set clearly and effectively. By using graphics. That is the most important thing. The best visualizations make it very easy to comprehend the data at a glance. They take complex information, break it down in a way that makes it simple for the target audience to understand, on which they can take their own decisions. Okay. So concluding visualization, your data can be both fun and challenging. It is very much easier to understand the information in a visual compared to a large table with lots of rows and columns. Data visualization provides a bridge between business users and data scientists. So, data visualization is going to change the way our analysts work with data. They are going to be expected to respond to issues more rapidly. Data visualization will promote that creative data exploration. Now, I think I'd like to summarize what we have learned for the past, I think, 1 hour. So let us summarize what we have seen so far. We talked about the need for data science, where data science can do, and what is data science, and what are all the prerequisites of data science in terms of skills and programming languages, tools, and so on. We also talked about the various data visualization techniques that are available, and we did a comparison between artificial intelligence, machine learning, deep learning, and data science. And I think we did a detailed discussion about the life cycle of a data science project with example, and last but not the least, we talked about the demand for data scientists and the various data visualization tools. With that, I think we come to the end of this session, right? Thank you very much for your patient listening. If you have any queries or comments, please put it in the chat box. I hope you learned something today about data science, some basic ideas about data science, what data science is, what are all the purpose, need of data science. I think so. So feel free